Recording. All right, guys. Good evening. All right, so today we're going to have our review session. So before we get started, I just want to go over some logistics for your upcoming exam, right? So your exam is going to be next Tuesday, and just let's go over how you're going to sign in. So for the exam itself, you need to, number one, sign into the Zoom session like what you're doing right now, okay? But before you do that, you're going to make sure that you have your camera turned on, all right? So that's going to be so important because that is the only way that we can proctor this exam, right? Because it's not like the alternative would be everyone to show up on campus, sit in a room and have someone stare at you for an hour or so. So we don't want to do that. You want to do it remotely. So in order to accommodate that and make everybody happy, you must have a camera. So the camera must be turned on. And again, it has to be you. We can't turn on and see that you have like a picture there, some animation, or or have the background you covered up. So please enable, because you know what? We're not just looking at you. What they're there to do is monitor to make sure you are taking the exam by yourself, which means that, unfortunately, for some of you, we need to see the background. We can't see if someone like standing behind you doing the test for you or telling you the answers. All right. So again, camera must be turned on, no filters, no backgrounds or whatever. We need to see you, and specifically, we need to see you by yourself. So what does that mean? Is that if I see your eyes darting left and right, it's okay, because the exam is open notes, it's open book, it's open, your computer, everything's cool. But what you cannot do is if we see you talking and you're turning left and right and it looks like you're obviously talking to someone, that's going to be a problem. Okay, so again, don't get caught doing that. Number two, once you have Zoom set up, you are going to open Blackboard and go to the scheduled syllabus where you see here, right? And I think sure all of you are familiar with this website. You would just go, there would be another link down here after the next class for midterm exam. And that will be enabled on the day of the exam, which means next Tuesday at 7 o'clock, it becomes enabled. Until then, you won't see it. So there's nothing for you to click on. It appears exactly at 7 o'clock. All right. So at 7 o'clock, it becomes enabled. You click it and you start the exam. So this exam is entirely online. It's entirely multiple choice. So we haven't finished the exam yet, but it's going to be anywhere from 40 to 50 questions, multiple choice. And you're going to be roughly get like a minute a question. So it's going to be like 50 minutes. Okay. So it's a time test. Most of the questions you should be able to, since it's multiple choice, add some true false. Some of these you should be able to do in like a few seconds. So again, on average, it should take you roughly a minute per question. And there's going to be a handful of questions that are harder, but the vast majority of questions are very straightforward and simple. Okay, so they're all worth the same number of points. So if you are stuck on a question and you don't know, again, if you can look, it's open books, you can look it up, you can get the answer within a minute, fine. If you find that you're spending 5 or 10 minutes on the first two questions, that's going to be a problem, because the questions are worth the same. And most of the questions are going to be easy with a handful of hard ones. Okay. So if you see a question that's really, really hard, skip it, because it's worth the same amount of points. All right. So with that being said, some of you have emailed me special accommodations, like that you've been already approved by the university for extra time or whatever. So if you have emailed me, you're all set. If I haven't responded to you, then there may be an issue. Okay. So if I responded to you, great. If I have not responded to you, then please email me just to nudge it to the top of my list, because all I have, it's very straightforward on my end to enable extra time. Again, the only way I can do that is if I receive some kind of authorization. And again, reach out to me, because I think some people have emailed me at the beginning of the course, showed me their ID and authorization letter. So that's perfectly fine. Okay. And if I responded, you're good to go. If I haven't, please email me, and it's sort of like a nudge, and I will check again, and then I'll enable it. All right. With that being said, do we have any questions before we start the review?
Yeah, Professor. So first we join the Zoom call and then we start the test?
Yes, join the Zoom
Okay.
call because again, you can sign on to Zoom because the test timer starts when you start the exam. So you're gonna have the window of like 10 minutes to sign into the exam.
Awesome. Thank you.
All right, but you need to have Zoom up because
Yes.
if you don't, if basically what I'm going to do is I'm just going to see how many people are on Zoom, and then I can see who's taking the exam. If you're not there, if you're taking the exam, I don't see you on Zoom. Guess what's going to happen? Since we are recording it, we know who's taking the exam or who's here. Your exam will not be graded. That's why it's very important that you sign into Zoom first.
Will it be the same meeting link as we're using right now?
Exact same one, correct. Oh, yes. Thank you. That just reminded me. When you sign in, please make sure that your meeting link, you use your first and last name. Don't try and get clever and use your nickname or your handle or whatever it is. So the name, when you signed in, has to match the name that is on the attendance or the registrar. Okay. All right. Other than that, any other questions?
Oh yeah, Professor. I'm not sure if you mentioned it or not. I came a little late, but where is the exam going to be located?
I just mentioned this a minute ago. When did you sign on?
I
A
was
minute
just
ago?
my head was somewhere else. Sorry.
All right. So it's going to be here. Look at this. Under schedule and syllabus, it's going to be here underneath the next class.
Okay,
All
got
right.
it. Thank you.
All right. Anyone else? Okay. So no other questions. Let's just dive right into the review. All right. So let's talk about these this worksheet. All right. Let's go through these problems together. So the material on these worksheets are designed to just cover as a review of all the topics we've covered since the beginning of class. So your exam is multiple choice, right? So obviously there's no need to show any work. You'll get questions. Some are really straightforward, like convert the following to a decimal, and then you'll do it on paper or whatever, and you'll write the correct answer in. Others types of questions, again, lend themselves to multiple choice type questions. Okay. All right.
Professor,
Yes.
so I take all my notes on my iPad. Is it fine if I use my iPad?
That's fine.
Okay.
Yeah. The only thing you're not allowed to do is have another person sitting there,
Okay.
or have someone else help you with the exam, which means they don't have to sit there. It's like, for example, if we find that someone else is actually remoting into your laptop, wherever, to help you with the exam, that's going to be the problem, right? Again, can we confirm that 100%? No, but if we see, since we're recording you, if we see you turning your head left and right, and you're obviously talking, that's a dead giveaway, right? Another is if you do absolutely no work and all of a sudden you answer like all 40 questions within 10 minutes, right? That's very obvious you just copied it. Because yes, the Blackboard does show when you enter every single question and when you submitted it. So, these are dead giveaways. So please, don't put me in a position where you get in trouble because this is very, very strongly enforced, especially since it's online. There's always a stigma attached to, well, it's not as hard, and is there that rigor associated with it? So that's why if it's online, we're extra sensitive in terms of people cheating or having those type of issues. That if we do catch someone, then we're going to make an example out of you. So please don't put me in that situation.
Professor,
okay? Yeah.
Are we allowed to Google during the exam?
Yeah, Google it. Fine.
Sweet.
Okay. All right. That's what open book, open notes means, because it's anything you need to help you get this done. All right, other than an actual live person. All right, let's get started. So let's do the first couple problems. I'm going to copy this into the whiteboard. So the first set of problems are number-based problems. All right, so the first one is 1 0 1 0 0 1 0, right? This is base 2. So what we want to do is convert it. Remember, this is just number bases. So it'll be 1 2 4 8 16 32 64, right? And then you just add it, and this will give you 82. All right, next one is base 16. Exact same concept, except the number base is base 16. So E is the value 14, and this is 14 times 16 to the 0. A would be 10 times 16 to the 1, and 1 times 16 squared. You add it all up, this would be 14 plus 160 plus 16 times 16 is 256. If you add all that up, this would be, let's see, what is it? 360, 416, 430. Okay. All right. Hopefully the first two are just simply add things up. All right. Let's do the next two or next three. All right. We have 231, and this is base 8. So it's 8 times 1 times 8 to the 0, 3 times 8 to the 1, and 2 times 8 squared, right? So this is 1 plus 24 plus 8 times 8 is 64. 64 times 2 is 128. If we add all that up, this is going to be 148, 52, 153. All right, so the next one isn't really a number base, it's BCD. So BCDs, if you recall, are groups of 4 bits that represent a number. So if we take these, break it apart in 4 bits, this is 73.8. All right. Now the last one, we haven't shown you any base 3. We did base 8, base 2, base 16, base 10. We never did base 3, but this is just show you that once you understand how number bases work, you should be able to do a base 3 problem. This would be 2 times 3 to the 0. This would be 1 times 3 to the 1. This would be 0. This would be 1 times 3 to the 3. And this is 2 times 3 to the 4. Okay. Add it, multiply this through. This should be 2 plus 3 plus 0. 3 times 3 is 9. 9 times 2 is 27. And 3 times through the 4th is 27 times 3 is 81. 81 times 2 is 162. And now we just add it all up. And this will be 27 plus 3 is 30. 30 plus 162 is 192. And this is 194. Okay. All right. Any questions on the number based problems?
So Professor, it's 82, 430.
82,
The first ones.
430. Where do you talking about? I don't see 80, 430 on this page. Are you talking about the prior
No,
set
the
of problems?
prior, the first two, because you went away. So
Did you do this already?
yeah, I did. I'm just I'm basing it off of what you did.
Well, yeah, hold on, let me pull it up. $82 and $430.
Thank you.
Yeah, guys,
That's the-
we told you, hopefully you guys did this already and you're just confirming you got the right answer, right? If this is the first time you're doing this, that's bad, guys.
No, this is not the first time doing it. I'm
Sorry.
just double checking.
All right, that's good. That's good. I'm just warning everyone else. If this is the first time you're doing it, then you guys are missing the whole point of doing this. right.
Professor, for the BCD questions, we should assume that it's compressed, right?
Yes. No, assume it's yes. Well, right now we're not talking about storage. So when there's no mention of storage, assume it's compressed.
Okay.
All right, next problem. Oops. All right, so the next set of problem is convert to binary.
Professor,
Yes.
sorry, my mic wasn't working, but I was trying to ask you a question about one of the previous ones.
Mhm.
You don't have to go back. I just wanted to ask for the BCD. I don't think I saw that you had like we went over when you have like a decimal point. So do we just assume the decimal point is like the same on how we would normally
Yeah,
have it?
if
with,
it's
like,
there, just
decimal?
leave it there. Remember I said it's implied.
Okay. So we'll like, if we see like, we still consider that there's a way to have like zeros at the end, in the regular way where, like we learned that there's two spots for zeros.
Well, yes, but that's
Better.
that's called implied fixed point, right? Because I would have to explicitly tell you that it's there. Because if I don't tell you, then that's whole definition implied is that there's no way for you can tell just by looking at the code. So I have to explicitly tell you that there's a decimal point there.
So on the exam, we'll see like a decimal point instead of the.
Right. That would be my way of explicitly telling you that it's there. But there's
Okay,
no way
thank
for you to encode it. Okay, that's why that's why I said it's implied.
Okay, thank you.
All right, no problem. All right, next, convert to binary. So the first is 2FB, and this is base 16. So hex is groups of how many binary bits, guys?
4.
4. So we break this into 4. So B is 1011. F is 1111, and 2 is 0010. And that's it, right? Very quick and easy. If you know it's 4 groups of 4, very quick translation. Next is an octal, 58. So octals are groups of how many?
3.
3, exactly. So now we break this apart. This is 100, and 5 is 101. Done. Okay, first tier easy. Last, 127. So 127 convert to binary. There's 2 ways. You can actually, there's more than 2 ways of doing it. One way is divide by 2, right? Divide by the number base. If you do 127 divide by 2, you'll keep dividing. You'll end up with 1, 1, 1, 1, 1, 1, 1. Okay, so how do I do this? Well, I can keep dividing by 2, which is one way of doing it. The other is my powers of 2. 128 is this, right? It's 1, 2, 4, 8, 16, 32, 64, 128. Okay, so that's 128. So 127 is 1 less than 128. So I would just take the top number, subtract 1, and I'll end up with a number below. Okay, so again, however you want to do it, up to you. But the exam is not going to say you have to do it any certain way. So as long as you get the right answer, I'm happily give you full credit for it. All right, next. All right, so next is integers. Convert -20 into the following formats. All right, so -20, we want first sign magnitude. So sign magnitude, the sign bit is 1 for negative, right? And the magnitude is 20. So 20 in binary is 1, 0, 1, 0, 0, 1, 2, 4, 8, 16. Yeah, so this is -20 in sign magnitude. 1 for negative, and then 20 in binary. So the next is 1's complement. So the difference between 1's complement and sign magnitude is you still have the sign bit that didn't change, but the magnitude bits are flipped when it's negative. So this becomes 0, 1, 0, 1, 1. Okay, so that's the difference between sign magnitude and 1's complement. Now for 2's complement, we just want to know what's the difference between 1's complement and 2's complement. So this will be 1, and then it's just what 1's complement, except we add 1 to it. Okay, so we've added 1 to the 1's complement, and we ended up with 2's complement. And that's done. So if you understand one of these, it's very easy to convert to the other two once you understand the difference between 2's complement and 1's complement and 1's complement to sine magnitude. So excess 50. So excess problems. Remember we said do it this way. Create a table. Excess 50 to decimal. 0 corresponds to negative 50, right? So we want to know what negative 20 is. So negative 20 going in this direction is I'm adding 50 to it. So 50 plus negative 20 gives me 30. All right. And then I'm not done because 30 needs to be converted to binary. So binary for 30 would be, I think it's a 1, 1, 1, 1, 1, 0, right? 1, 2, 4, 8, 16, 30. Oh, hold on. I put one extra one here. There you go. So that's 30 in binary. Okay. Any questions on integers? All right, moving on to the next group of questions. Now we have convert this fractional number into a binary. Okay, so 233, we break this in half. $233 would be 233 divided by 2, and we keep track of the remainder, right? If you divide 233 by 2, you're going to have a remainder of 1, and then it's going to be 116. So 116 divided by 2 would have no remainder, and this would be 58. 58 divided by 2 would have no remainder, and this would be 29. 29 divided by 2 will have a remainder of 1, and it'll give you 14. 14 divided by 2 would have no remainder, but it gives you 7. 7 divided by 2 would give you a remainder of 1, and it would be 3. 3 divided by 2 would give you a remainder, and we'll have 1. 1 divided by 2 would give you a remainder of 1, and that's it. So once I have this, it's going to be from bottom up. So it's going to be 1, 1, 1, 0, 1, 0, 0, 1. So that's 233. Now for the fraction side, 0.625, instead of divide by 2, now it's multiply by 2. So you multiply by 2, this would give you 1.250. And what I want to do is I keep multiplying the fraction. So 0.250 times 2 gives me 0.50. And I keep multiplying the fraction. Okay, and now I can stop because it's all zeros now. And from this side, I'm changing the ink color. It's going to be opposite, top down, right? So it's going to be 1, 0, 1. All right, and this is your binary fraction for 233.625 base 10 is going to be this number in binary. All right, any questions on this? All right, moving back, let's to the next problem. All right, so next we have a series of arithmetic problems. And very important thing, always read the instructions. So these are 2's complement problems. So 2's complement means that these are signed numbers, okay? So again, very important that you read the instructions. So this tells me that these are signed numbers. And then is it just interesting getting the answer? Not really, because it shows indicate errors due to overflow were applicable. So it's not, I'm not interested if you can do math. I'm really interested saying that, yes, you could do the math when it's possible, but however, if you think that there would be an overflow issue associated with this, I need to know, or you need to indicate that there's going to be an overflow issue. Okay. All right, let me just copy this into the whiteboard and let's do this. Okay. The first problem, 0, 1, 0, 0, 1 plus 0, 0, 0, 1, 1. If I add that, this is 2, 2, 1, 1, 0. Okay, so is there overflow here?
No.
No, this is the right answer. Next, 0, 1, 0, 0, 1 plus 0, 1, 0, 1, 0. 1, 1, 0, 0, 1. Okay, is there overflow problem here?
Yes.
Yes. Why? You gotta explain why. Because remember, when you can't do it, you gotta explain why. Why is there overflow?
Because it became a negative in the by adding the 1 at the front.
Exactly. So if someone see that this is a positive number plus a positive number, and you ended up with a negative number, that's how I can tell there's an overflow. All right, next problem.
And do we have to like know the difference between like physical and logical overflow?
If it asks, yeah, if it asks you, again, your test, it's open game. If we covered it in class, then you're responsible for it.
Professor, so we don't care if like the number of the output bits is more, we just care about whether the sign changed, if we're adding the same signs.
Well, that's how you can tell there's overflow, right? For signed numbers, right? We covered this during our lecture.
Right, but we don't care about, for like the twos complement, we don't care about whether or not the number of output bits is different, right?
Right, because didn't we cover this, that the number of output bits doesn't affect the answer?
Yeah, okay.
All right. So 1, 0, 0, 1, 1 plus 1, 1, 0, 1, 0. We add that, this is 1, this is 2, this is 1, and this is. So is there overflow here?
Yeah.
Okay. How? How do we know?
It's two negatives and you got a positive.
Exactly. So negative plus negative, we end up with a positive. All right. So I'm going to highlight in different color. We don't care about this bit because it's discarded. Because we covered that we're dealing with integers, we don't care. The presence or absence of the extra bit makes no difference on the answer. To detect errors for signed numbers, you look at the sign bit. Okay, next. 1, 1, 0, 1, 1 plus 1, 1, 1, 0, 0. This is going to be
Professor.
1, 1. Hold on, let me finish this one first. 1, 1, 1. This is 2. Okay, so is there overflow here?
No.
No, because the answer is correct, because we're going to discard this. This is discarded. And what we're keeping is negative plus negative, ended up with a negative. You're good to go. All right. So does someone have a question?
Yeah, I was going to ask for the previous one. Would we say there was both like a physical and logical overflow?
No, because we don't care about the extra bit. When we're doing this, the answer, as long as we get the right answer, it doesn't matter, because that thing I highlighted in pink is being discarded, so it doesn't affect my answer. Look at the most recent one. Look at this problem, the fourth problem. Notice that I have this extra bit, but it doesn't matter. It's not being stored anyways. Is my answer correct? Yes, it is. Okay, so again, if you're dealing with signed integer addition, the absence or presence of that extra bit on the left in pink is not relevant. It has no impact on your answer. Is that clear?
Yes, thank you.
Okay. All right, let's move on to the next set of arithmetic problems. Okay, so the first one here, 0, 1, 1, 0, 0 minus 0, 0, 1, 1, 1. So they're arithmetic, these are integers. So I don't want to subtract because if they're integers, I can change the sign. So I want to change this into an addition problem, right? Remember the a minus b is rewritten as a plus negative b, right? So I want to change this to an addition problem. So to change the addition problem, the top stays the same, but the bottom, we change the sign. So if it's currently positive, we're making it negative. So we flip the bits and add 1. So it's 1, 1, 0, 0, 1. And now we add it. This is 1, 0, 1, 0, 0, 1. And then, of course, I discard this extra bit. All right. And there's your answer. All right, next
Professor,
one.
can you explain that again? The bottom, just flip the signs.
Yeah, look. We're changing a minus b to a plus negative b. Okay, so what we're doing is changing this subtraction problem into an addition problem. All right, next, 1, 1, 1, 1, 0 minus 0, 0, 0, 1, 1. All right, so same thing. We're going to change this to an addition problem. So the top stays the same, and the bottom is now plus. It's 1, 1, 1, 0, 1. And we add it. This is 1, 1, 0, 1, 1, 1. And then I discard this bit, and there's my answer. All right, so the last problem on here is, I'm going to shift this over, is multiplication. So remember, integer multiplication requires either sign extension, right, or changing everything to positive. Okay, so let's just do change everything to positive. So the top number is currently negative, so I want to change everything to positive. So this needs to become 0, 1, 0, 1, 1. And then I add 1 to that, and this would be 1, 0, 0. Okay, the bottom can stay the same because it's already positive. Now that I have that, then it's just multiplying this through. Since everything's positive, okay, and then 0, 0, 1, 1, 1, 1, 0. Okay, so now that I have that, now comes a question: 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have to double the number of bits, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so can I leave it at that? And the answer is no, because after I do it, I look at my original question. 1 was positive, 1's negative. So my resulting answer needs to be negative. So currently it's positive, right? Everything's positive. So I need to change it to negative. So to change to negative is just flip the bits and add 1. So this becomes 1, 1, 1, 1, 0, 0, 0, 0, 1, 1. And then I add 1 to it because it's always flip the bits and add 1. This becomes 1, 1, 1, 1, 0, 0, 0, 1, 0, 0. Okay, and that's your answer.
So Professor, for that problem, you could technically just switch the signs to positive and then just convert it to decimal and then like
Convert to decimal. Well, if you want to convert decimal, yeah, sure. It's up to you. But yeah, if you want to do it that way, but ultimately, as long as you know this process, you know what I mean? Because what if we get a question that doesn't require translation? What if I say, which bits do you need to look at? Right? So yeah, sometimes multiple choice questions are more than just do the problem. Sometimes it's asking about the process itself. It's like, for example, what if you get a question, how many bits is the answer going to be? Right?
Right, got it. That makes sense.
Professor, why is this not an overflow error again?
How do you have overflow here? This is multiply. You have double the number of bits. How would you have overflow? Remember we talked about multiplying is what's the output size in comparison to the input size for multiplying? We cover this.
I must have forgotten about that. I have to look that up.
Okay, so anyone want to help him? What's the relationship between input size and output size when it comes to multiplication?
Doubles?
It's double?
Double, yeah. You got it? If it's double, it's not going to overflow because you allocate enough bits that would never overflow.
All right, thank you. Understood.
All right. All right, next. All right. The last two problems on here are going to be floating point questions. All right, so negative 12.25. So first step is to convert it into binary. So negative 12.25 in binary is negative 1100.01. Now I normalize it. Next step, this becomes 1.10001 times 2 to the 2 to the third. Okay. All right, everyone should have gotten up to this step, right? All it's doing is taking a decimal number and converting it to a scientific notation binary. And it's normalized, very important. We need to normalize it to 1 digit. After we have this, now let's do single precision. Single precision means that, okay, we have a sign bit, is 1 for negative, and then the excess is 127 to decimal, right? So 0 corresponds to negative 127. I have a 3 here. So going in this direction, this is 130. So 130 is 128 plus 2. Okay. And then my fraction is here because I have a hidden 1. So it's 10001 followed by a whole bunch of zeros. All right, that's it. Now for the long, the double precision, not long, sorry, the double precision, you have a sign bit, just the same. And now for the exponent, the excess is 1023. So it's going to be a little bit longer and bigger. So 0 corresponds to negative 1023. And we want to know what 3 corresponds to, right? So 3 is going to be 1026. So 1026 is 1024 plus 2. Okay, so that's 104. I'm sorry, 1024 and 2. So you put them together, it's 1026. And the fraction is going to look the same. Okay, but what's very important though is even though I'm writing it this way, know that all I'm doing here is say there's a bunch of zeros in between. But you need to remember that this is 23 bits. This is 52 bits. Okay, so you have to know that the total number of zeros there is a lot more in the double than there are in the single. But even though I just put ... it means there's a whole bunch of zeros, means I don't want to write out 48 zeros. but you need to know that there's gonna be 52 total digits here. And there's total of 23 digits here. Okay, does that make sense? All
Yes.
right,
Yep.
okay, now let's take a look at the next work set. All right, so the next work set focuses on BCD. All right, so let me magnify this. So BCDs are groups of 4, right? So I'm just gonna put groups here, separated just so it's easier to see. All right, so the first problem, it's asking convert the following BCD values to decimal. If it's not possible, state why. So this would be 1, this is 9, 9, and 5, and done. The first one's easy. Next one. This is 5, 2, and this is C. So what's 52C? What value is represented by 52C?
Positive.
Yeah, it's positive 52. All right, because this is an integer. All right, next one. We have 50, 5, 2, and this is A. Is this a valid BCD?
No.
No, because A is not a BCD value. All right, next. We have 7, 8, D. So what's this value here? Guys, anybody, what's the value here?
Negative.
Negative 78.
Exactly, D represents negative, so this is negative 78. All right, last one. This is D5, 5. All right, so D5 is what? Is this valid, BCD?
No.
No, because the sign bit, right? The sign needs to be toward the end of the number, not the beginning.
Isn't that C?
Is that, oh, my bad. C55. It's still not about BCD because the sign needs to be at the end, not at the front. All right, next set of questions. UTF-8. So assume the following binary values are encoded UTF-8. What are the code points? All right, let's think of the first one. Is the first one a valid UTF-8 encoding?
No,
Why? Why is it no?
because the second byte needs to start with 10.
Correct. So this is a problem. So this is wrong. All right, good. Next one. Is the next value a valid UTF-8?
No,
Not why?
because it's 3 bits.
Exactly. This indicates that there should be 3 bits, but there's only 2. All right, next. Is the next one valid UTF-8?
Yes.
Good. So what's the value? So this is part of the template, right? So the value would be what's underlined. So it's 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0. And you want to do groups of 4. So this is A6. So it's Unicode point A6.
So
All right.
you wouldn't have to pad that with zeros. You wouldn't have to say U plus 0, A6. It's just that's
U
fine.
plus, no, you can put zeros in front, doesn't matter because this is A6. You know, you can have 1,000 zeros in front, doesn't matter. It's still A6. Okay, because it's not a sign bit. If you had signs, then that'd be an issue, but we don't. So yeah, you can put zeros in front, doesn't matter.
Cool, thank you.
All right, next. So is the next one valid UTF-8?
Yes.
Okay, let's see what the value is. I'm gonna underline the ones that. So this is 0, 1, 0, 1, 1, 0, 0, 0, 0, 1, 0, 1, and then 0, 0, 0, 0. And then groups of 4. Okay, so this is A1A. So it's Unicode point A1A. All right, any questions? All right, moving on. All right, so now we're moving on to floats again. But this time we are gonna look at the special case floating points numbers. Remember we said that if you get a float, first thing you should look at is the exponent. When the exponent is all zeros, right? Like here, it could mean it's either 0 or denormalized number. So because the fraction here is not all zeros, that means this is a denormalized number. So denormalized means that your exponent is fixed at 2 to the negative 126, and there's no hidden 1. So this is negative 0.101, okay? Because it's denormalized, there's no hidden 1, so it's 0 point and the fraction. Let's look at the next number. The exponent is 3, right? So because the exponent is 3, it's not all zeros and not all ones. This is just a regular float. So excess 127 to decimal, 0 goes to negative 127, and this is 3, right? So 3 would be negative 124. Okay, so this will be times 2 to the negative 124. And then it's positive, and there's a hidden 1 because this is a regular float, so it's 1.101. All right, the next one.
Professor, you didn't want us to convert it to decimal? Yeah, but it says what decimal value?
Oh, let's, oh, hold on.
Okay.
Okay. Sorry, it's like this is contradictory. So yeah, but I think this is ultimately, what I'm searching for, because I don't see any value for you to multiply 2 126 times, right? So yeah, that didn't make sense to me. All right. The next 1, 2, 3, 4, 5. Okay, so this is all ones. So it's all ones. This is going to either mean 2 things. Either it's going to be infinity or not a number. So I look at the fraction, it's all zeros. So I realize, oh, this is just infinity. So this is positive infinity. All right, next one. Okay, so this is another case where it's not all zeros or all ones. So this is yet another regular float. So my going to do the excess 127 to decimal conversion. So 0 goes to negative 127. This is all ones and a 0, so this is 254. So 254 going this direction is you'll end up with 127. All right, so this is times 2 to the 127. And then the fraction has a hidden 1. So it's 1.0 times 2 to the 127. The next one's easy, it's just 0.
So Professor,
also-
for that, sorry, for that last one, that's like the largest exponent, right? So the largest exponent would be 127.
Correct.
Got it. Okay.
All right, now the last problem. I'm just making sure. Okay. All right. So this is a regular float again. So excess 127 to decimal conversion. 0 goes to negative 127. This is 1. So it's going to be negative 126. So this is times 2 to the negative 126. And the fraction has a hidden 1. So it's 1.0 times 2 to the negative 126. Okay. All right, now our last problem here. This is all zeros. So this is a denormalized number. So denormalized means that it's fixed at 2 to the negative 126. And there's no hidden 1, so 0.1. And that's it. Well, yeah, that's our last problem. All right, guys, any questions?
So when the exponent is all ones, it's automatically infinite, right?
Right, when the exponent is all ones, it can be either infinity or the other thing was not a number, right? We covered that during our review of denormalized numbers.
Okay, thank you.
Professor, people are asking on the chat if we could backtrack on the midterm. Like, could we go back to the previous question?
No, unfortunately, that's one of the tough decisions that had to be made, is that basically the exam is made so it's hard, and then as it's harder to cheat, not the content, but it's harder for people to be unethical, which means there's no backtracking and the questions are random order. So this is to address the possibility that what if I have two people sitting in the same room and then they're just taking tests next to each other, as a group, right? So this will discourage that, because when you sign in, your questions don't come in the same order. And since they don't come in the same order, once you get to a question, you can't backtrack, just so you can't say, oh, that was the wrong answer, and go back and change it. So everything's random and there's no backtracking.
Wait, I'm not understanding. What is backtracking?
Backtracking means that let me skip this and go back to it later.
So once you answer your question, you can't.
Correct. It moves on to the next question. Correct.
That's rough.
Professor, what if you just didn't answer it? You didn't leave like one of the answers. You just
if you don't answer, you get a 0. So always pick an answer.
Okay, got it.
So are we shown one question at a time then? Is that how it works?
Yes, exactly. Yep. All right, guys, any other questions?
Professor, I actually have a question.
Go ahead.
For the overflow questions, I don't know if you went over this, but I mean, I'm assuming that the test is multiple choice. So if there is overflow, you'll just there will be an option for overflow.
Yep. Of course.
But it's not like something we need to like indicate in some special way or something. There's just going to be an option for it. That's
right, because it's multiple choice.
All right. Yeah, makes sense.
Yeah, that's one of the downsides of online classes, is the testing is very, again, guys, I understand it's very onerous. It's not designed to be super friendly and easy, but these are unfortunately realities. If you want to administer something online, and unless you want to pay to go to Prometric or one of those proctored exam places where they pat you down and check your pockets and put cameras on you, and you know what I mean? Actually, has anyone here taken a professional exam certification somewhere? I'm assuming that's a no. Okay, so I have taken a lot, I've had a lot of certifications. So the general rule is that if you want to get certified like Microsoft or any one of these other vendors, they contract out with these testing facilities, and you walk in and it's sort of like at the airport, they pat you down, make sure there's nothing in your pocket, and then you sit down at a desk and there's a camera looking at you and there's a camera on the entire room, and literally you start the test and everything's electronic, multiple choice, it's on a timer, and some will let you backtrack, some won't. But the whole idea is that, you know, it's a very, very restricted environment. So unfortunately, I don't think where like CUNY or Queens College is anywhere approaching, you know, doing that. But unfortunately, this is the next, you know, best alternative, right? Short of making everyone go in person in a classroom, sitting there with people looking over your shoulder. So again, my apologies, but this is a necessary evil. But the trade-off is you get to do it from the comfort of your home. You don't have to commute out. You do it on your computer. So, you know, there's pluses and minuses. Oh,
So-
speaking of your laptop on your computer at home, make sure that you have a stable internet connection. I don't want to hear any sob stories later on about how your internet connection was flaky, or, you know, you're taking this test at Starbucks on a free Wi-Fi, and then, okay, again, it's your responsibility because you signed up to take an online course, so you are responsible for having a stable connection.
So the test isn't curved, but you said the class is curved.
The whole, yes, the final grade is curved, individual tests are not, because you have multiple grades for the course.
So does that curve work? Like if the highest grade was 95, everyone gets 5 points?
No, I don't know. It depends. That's what a curve means, right? Is that if everyone does really poorly, then the curve will be higher. If you have one guy who kills the curve, then it's going to really suck for everybody else. But again, definition of curve means that it's curved just so that you have a normal distribution, or at least as much as possible. The normal distribution is the bell curve.
Oh yeah.
So it wouldn't be curved down, right?
No, come on. I'm not going to do that to you. No, that's not reasonable. If everyone here like gets like all A's because they legitimately did it, then no curve is necessary. And then I would submit that. And what would happen is the department would contact me saying, what's going on? How come everyone got an A in this course? You know, because again, there's pressure to say, all right, it needs to be graded on a curve, because having taught this for over 10 years, I know any given class, you'd be shocked at how often that you end up with a bell curve, because that's just how people behave in any given group. That's what always eventually happens. So it'd be very unusual. If it happens, I'd be happy, because you guys have documented all your work, and if everyone got A's, fantastic. But I have never seen that before.
Professor, for the converting like base N to base K questions, like those, the amount of digits that are required, it's not like a specific or anything. It's not like binary arithmetic or anything. It's just like implied.
Nope. Correct.
Just like basically the least amount of digits is the answer, essentially.
Yeah. Again, yeah. So look, it's multiple choice. So there's only be one right answer. I'm not going to do that to you. Say, hey, I give you like 3 versions of the same answer just to mess with you. No, I don't do stuff like that.
Professor, I just wanted to mention, I think if I remember correctly, I think your notes for, I think it was lecture number 3 where we learned about sign magnitude. I think it was off because you said that the range for sign magnitude where there's n amount of bits, then there is -2 to the n minus 1 to 2.
Right,
to the
because
n.
one of the bits is used as a sign, so you lost about a magnitude bit.
Right, so that's why it would be -2 to the power of n minus 1.
Yeah, and -1 because you lost a bit.
Yeah, so I think your notes might have said -2 to the n.
No, but as long as you understand the concept, you lost 1 bit. Okay,
Yeah.
so given 3 bits, 1 bit is used as your sign bit, so you only have 2 bits left for the value.
Yeah, I just wanted to mention that. I think your notes was
Okay.
okay.
For these last questions, you say to put it in scientific notation, but like the answers that you're accepting is like 0.1 times 2 to the negative 126. Like we wouldn't have to
Yeah,
like,
this is scientific notation. Binary scientific notation.
but would the last one be scientific notation because the number, the
This?
decimal number is less than 1?
This?
Yeah,
That's fine.
that's
That's
not.
fine. If you really want to do it, it'll be 1.0 times 2 to the negative 127, is it?
I think maybe 125.
125, okay, yeah. But on your exam, there's only gonna be one right answer, okay?
Yeah.
So
Don't worry.
again, if you're looking at it, they're technically both scientific notation, unless I tell you to normalize it.
Understood. Thank you.
Professor, can you scroll up a bit? I want to check number one here.
Scroll up, how far up?
Oh, no, the second slide.
Here?
Yeah, that's good. Thank you.
All right, no problem. All right, guys, any remaining questions? All right, since there's no more questions, then good luck on the exam. The exam will be, again, sign into Zoom and log into Blackboard at 7. And you should see the exam is posted. Once you sign in, you're gonna have probably 45 or 50 minutes to do the test. Okay, so find a nice quiet place that's not interrupted and with a stable internet connection, and you should be good to go. All right, then have a good weekend, guys, and good luck next week.
Thank you, Professor.
All right, have a good one.
Thank you, Professor.
No problem. Have a good one, guys. Yes, someone had a question?
Yeah, I wanted to show you something privately, but I don't know if like.
All right, so let's, everyone, unless you have something, have a good day. Let's see, who was it? Let me see, Steven. All right, let me see if there's a, can we do is there a breakout room or? All right, let's see.